Good morning, ladies and gentlemen, and welcome back to episode 2 of Fighting for a 5, where we go over the document problem number 2. Of course, brought to you by Couch Potato Brand Snack Foods. The probability of delicious equals 1. Those are some pretty good odds, I gotta say. All right, ladies and gentlemen, let's take a look at this problem. There are a number of questions about this question, particularly for part C and D. So anyway, we're going to go through all 4 parts anyway. Part A says to let X be the number out of 4 selected left femurs that are from males. Based on how these bones were sampled, explain why the probability distribution of X is not binomial. Now, the thing is, X is a random variable, right? X represents a number. It's a count of number of males out of 4 of the femurs that were selected. So X could be 0, 1, 2, 3, or 4. All right, so this is a quantitative random variable, which so far could be binomial, but let's get into the reason why it's not binomial. So remember, a binomial random variable has basically 3 necessities, 3 conditions. Each selection has to have 2 possible outcomes. And in this case, each selection does have 2 possible outcomes. Either the femur will be from a male or a female. So far so good on the binomial front. Moving forward, each selection has a fixed probability of success. Well, if you think about the probability of a femur being a male or female in a vacuum, like the probability that a brontosaur was a male or a female, I think it's reasonable to assume that there's a 50-50 probability in the overall population I'm speaking of. So yeah, in general, each brontosaur bone, any random brontosaur bone that you encounter has a 50% chance of being male. So I would say fixed probability of success checks out. We run into problems in this third condition where each selection has to be independent and random. Now we do have random selections, apparently. It says that each of the 4 left femurs were randomly selected, but the thing is, they were randomly selected from a small group of bones. So we don't have independent selection. As we draw one bone from the population, and when I say population here, I'm talking about the group of 20 that we're currently analyzing. So when we draw one bone from that group of 20, we're now left with 19, and the probability now of being selected, or a probability of a male being selected, will change drastically. So instead of being out of 20, you're now out of 19. When you go ahead and draw a second one, your probability is now going to be out of 18 possibilities, and then down to 17. So the fact that we have such a small group of bones that we're studying means that our selections are not independent. And actually, I should say it's a small group, as well as the fact that we are not replacing. Okay? So this wouldn't really be your answer. I just wanted to go ahead and show you the definition of a binomial, or remind you of the conditions of the binomial random variable. But you'd say something along the lines of that this is not a binomial random variable because the femur selections are not independent. Okay. And that's what you'd say for part A. Okay, part B. Let me go ahead and use a highlighter. All right. Part B. Suppose that the group of 20 brontosaurs whose remains were found in the swamp had been made up of 10 males and 10 females. Now, this word suppose right there, that tells us that we are making an assumption about this group of 20 brontosaurs. So it's basically saying, assuming 10 males and 10 females, what is the probability that the 4 that you select happen to be male? And there's a lawnmower driving by. Okay, so sorry about that. All right, so assuming 10 male and 10 female, the probability of male and male and male and male, or in other words, the probability of 4 males, is going to be calculated by, well, your first selection, if there are 10 males and 10 females, then you have a 10 out of 20 chance in your first selection. Your second selection now would be 9 out of 19, because there's one removed from the group of 20, and that one was a male. And then 8 out of 18, and then 7 out of 17. And this probability ends up being 0.043. So it's a very low probability of this occurring, and that is going to be important in the next part of the problem. All right, so this would be a complete answer for part B. Part C, the DNA testing revealed that all 4 femurs were from males. So it turns out that we went in, we randomly selected 4 femurs from this group of 20, and it turned out that they were all males. Based on this result and your answer from part B, do you think that males and females were equally representative from the group of 20 brontosaurs stuck in the swamp? Explain. So hopefully when you read this problem, you're kind of thinking of a hypothesis test. Lawnmower. All right. So we're going to have to stop every once in a while. Hopefully, though, you kind of are thinking of a hypothesis test or something similar to a hypothesis test, because the probability we calculated is based on an assumption, sort of like the null hypothesis. Now, for part C, we want to say that if there are 10 males and 10 females, the probability of 4 males is equal to 0.043. So basically, I'm restating what we got in part B, because the question did ask us to use that result as an argument for or against equal distribution of males and females. So if there were 10 males and 10 females, the probability of 4 males would be 0.043. However, we actually observed this outcome. So now this means one of 2 things. We either got really lucky, or the initial assumption is incorrect. And of course, in statistics, when we make an assumption and we observe a very rare outcome that would, or an outcome that would be rare based on that assumption, we take that as evidence that the assumption is incorrect. Or in other words, we take that as evidence to reject the null hypothesis, right? So we would say, this is evidence that our initial assumption is incorrect. Okay. Again, the logic is, if there were 10 males and 10 females, then the probability of 4 males is less than 5%. However, we actually observed that outcome, right? That in reality, this supposed 5% probability outcome actually occurred. Now, did we get lucky, or was our initial assumption incorrect? And we don't really know for sure unless we go ahead and test all 20 femurs, but we use this as evidence that our initial assumption is incorrect. All right, that's how we interpret these results. And now part D. This one really was one that people struggled with because it's a little confusing. But is it reasonable to generalize your conclusion in part C pertaining to the group of 20 brontosaurs to the population of all brontosaurs? Well, what was our conclusion in part C? let me complete this thought, because I wrote that this is evidence that our initial assumption is incorrect. So really what that means is, in other words, these 20 brontosaurs are not likely 10 male and 10 female, or evenly split. Right? So that's the conclusion that we made about this particular group. Now, does that mean that the population of all brontosaurs were not evenly split male and female? Not necessarily. The fact is that we're drawing our sample from a group of 20 brontosaurs that we happened to discover. And so the fact is that this is a convenience sample, and there's a strong chance for convenience samples to have bias. So one way of answering this question is that we cannot, so let me just remind myself of the wording. Okay, yeah, we cannot generalize these results to the rest of brontosaur population. Okay, so that answers one part of the question. Now we have to, of course, give the reason, explain why or why not. The result from part C is based on an analysis from one group of 20 brontosaurs. This is a convenience sample. And is possibly a biased result. Okay, so this would be a fine answer. Obviously, your answer doesn't have to be exactly like this, but what they do like to see is some kind of statistical vocabulary. So here I use the term convenience sample. Well, I forgot to write the word sample. So I use the word convenience sample. I also use the word bias. And when they see this statistical language, that is what they like to see. And you're more likely to get the nod for a correct answer, or an essentially correct answer, because if you're using that language, then it kind of shows that you know what you're talking about. You have sort of mastered these concepts. Okay. So anyway, that is all for today. I'll be back tomorrow for a video on the document problem 3, and feel free, of course, to ask any questions or any concerns or anything like that. I'm free. You can contact me anytime. I won't necessarily get back to you immediately, but I will get back to you. All right, folks, hope all is well. Take care. Bye.